Hey everyone, welcome back to another video. I'm not going to show y'all my face today because I look busted and crusted right now, so not happening. But today we are going to start 10A. So with 10A, it is all about, it says interpret key features of graphs using graphs and tables. Okay, so the thing about Unit 10 is it's kind of bringing a couple of our units together, which is really nice because now y'all are going to get to see all the connections between it. So we're going to start with 10A. So today we're going to do notes, and that's going to be your lesson for today. And then your next lesson will be going ahead and doing some practice on it. So since we're going to be since 10 is our last one, we're going to be taking our sweet time on KC10 and really just making sure you'll understand kind of everything of this semester in order for next year. So let's get going. So 10A, it's got to get it. It's figuring its stuff out. Hold on. There we go. So with 10A, what we're going to need to remember is domain and range, right? We've seen those words before, but it was a long time ago. So I'm just going to kind of go over again what domain and range are. So let's start with domain. If you remember what domain is, shout it out. But domain is all of your X values, right? X values is one way we can say it. Inputs is another way we can say it. Independent variable, right? Those all mean the same thing. Right? We can use those three things interchangeably. So X values, inputs, independent variable. Right? So that's the domain, right? So all of your X's. So then range, right, is kind of the other part of this. So range is your Y values. Ooh, yikes. There we go. Y values, right? Or your outputs. Or the dependent variable. Okay, so I just wanted to go over that before we started kind of going into some examples, okay? So let's start going into some examples, right? Domain, X values, inputs, independent variables. Also, when we're expressing our domain and range, we're going to be using inequality. So we're going to be saying our X's are between what numbers for your domain, and then for the range, we're going to say what numbers your Y is in between, right? The numbers that's the minimum goes here, and the number that's the maximum goes here, right? We have done these before. So the number for your minimum, same thing with your X's, goes here, and the number for your maximum goes there. So you're just looking at what's the min and max of your X's and Y's, okay? So number one, we've got find the domain of the graph, and it gives you the function f of x equals negative x plus 7 with a range of 2 is less than or equal to y is less than or equal to 8. Express the solution as an inequality. So the directions, find the domain, right? What does that mean, find the domain? This means find the x values, right? Find all of your x's, because it already told you your y's. It told you y is between 2 and 8, so we have to figure out what x is between, right? If we look here, if we look at our y's, our y is between 2 and 8. So in order to find the domain, we have to find what x is between. So x is between here and here. So our x's are between -1 and 5, right? If we were to put the numbers here, right, -1 would go here and 5 would go here. So it says express the solution as an inequality, right? So that means use your inequality symbols. So we're figuring out x is between what number and what number. So the minimum goes here and the maximum goes here, right? So the -1, that's the smallest number, so that's your minimum. And the 5, that's the bigger number, that's your maximum. So -1 is your minimum, 5 is your maximum, and here is your answer. Okay? Next one, we've got another one very similar. So find the domain of the graph. F of x equals 2x minus 4, and it gives you your range, right? It tells you it's between 2 and 6, right? Which we see 2 and 6. So it says express as an inequality. So we want to find the domain, express it as an inequality, find out what numbers x is between, right? Because domain means x. It already said range, which means y. So that's why we had the letter y in between there. Holy cow, this thing really won't write. It's supposed to be a y, y'all. There we go. Right, range is y, domain is x. So we're finding the numbers that x is between, right? So we just take where our line starts and bring it down. That tells us where x begins, and then take the end of our line and bring it down. That tells us where our x ends. So if we look at these numbers, right, this here would be 3 and this would be 5, right? So that tells us that our x, it starts at 3 and goes till 5. Make that a little bit cleaner. So here's our domain. All right, next one. It says Morton West Stadium has a seating capacity of 6,000 people. For each football game, the amount of revenue R the Mustangs bring in is a function of the number of people P that attend the game. If each ticket costs $5, find the domain and range of this function. Okay, I know there's a little bit going on here, so let's break it down. So Morton West Stadium has a seating capacity of 6,000, so that means you can have up to 6,000 people in the stadium. Then for each football game, the revenue R the Mustangs bring in, revenue is the amount of money you make. So revenue is kind of like profit. So it's the amount of money that you make, you bring in, isn't a function of the number of people that attend the game, and each ticket costs $5. So we have to figure out the domain and range. So we've got the domain and the range. So we have to figure out, so it gave us two variables. It gave us R and it gave us P. We have to figure out between R and P which is the domain and which is the range. So you have to kind of figure out in this situation, is it that the number of people depends on how much money you make, or does how much money you make depend on how many people there are? Right, that second one makes a lot more sense, right? The number of people that come will then determine how much money Morton makes, right? You wouldn't be able to decide how much money they make before you actually count up the number of people that went. So the domain is always your independent variable. So in this one, the number of people is your domain, because your range, right, your range depends on your domain. So the revenue depends on the number of people that attended. Well, okay, so it told us to use the letter P, right? So this means we're going to be saying P is between what number and what number. So the minimum number of people that can go and the maximum number of people that can go. Well, the minimum number of people, that's pretty easy. You could have 0 people show up. That would suck, but it's a possibility, right? It told us right here, though, it has a seating capacity of 6,000 people. So capacity, right, that is another word for like the maximum number of people that can be there. Capacity, maximum, those two words mean the same thing. So if you're at capacity, you have the most number of people you could possibly have. So that tells us that the maximum number of people we could have in the stadium is 6,000. So we have our domain finished. So the revenue is how much money you make, and it also told us that we're making $5 per person. Right, so we're looking at, and it told us to use the variable R for revenue. So we're looking at the revenue, what the minimum revenue is, and what the maximum revenue is. Well, for the minimum, if 0 people show up, you're going to make, oh, that is so ugly. If 0 people show up, you are going to make $0, right? Well, but then you have to think, well, the maximum, right? The best case scenario is if 6,000 people show up, but the maximum wouldn't be 6,000 because you don't only just make $1 per person. So to find the max, it's $5 per person, but then we're going to multiply that by the 6,000 people that could possibly show up. So if we do 5 times 6,000, that gets us 30,000. So the max amount of money that you could make would be 30,000 because you got $5 per person. Okay, so it told us to find the domain and range, and we did, right? Here's our domain, and here is our range. Ooh, I forgot to put the inequality symbol. There we go. And then our last one, Madison Square Garden has a seating capacity of 18,200 people. For each basketball game, the amount of revenue R the Knicks collect is a function of the number of people. Sorry, got an email. It's a function of the number of people that attend a game. If the average ticket is about $123, find the domain and range. Okay? So again, we're finding the domain, and we're finding the range. Okay, so we have to figure out, right, the range needs to depend on the domain. So we have to figure out what depends on what. So does, again, we're using this word revenue, right, which means the amount of money that you make. Do the number of people depend on the money, or does the money depend on the people, right? It's pretty much the exact same as the last one. So the amount of money you make, your revenue, how much money you make, depends on the number of people that go to a game. Okay, so the number of people, so we're using P again for people. We have to find the domain, so we have to find the minimum number of people that can go and the maximum number of people that can go. Okay, so the minimum number of people, again in this case, is 0. 0 people could go to a Knicks game, right? Kind of like right now, ain't nobody can go because nobody's playing basketball. And then our other situation is if all 18,200 people go. So that is our domain all finished. The range is the revenue, and it also told us that they make, it's 123, that's not a 3, that's a 5. It's 123 per person. So for our R, we could either make $0 if nobody shows up, or for a max, if it's 123 people, right, we do 123 times all 18,200 people, right? Type it into your calculators really quick. Is 2,238,600. So there's your range. Hope you enjoyed. I'll see you again soon. Bye.